Today we have a call on a air conditioner not working. Now this is an old York Sunline, probably if I had to guess from the early 90s. Pretty beat up. Customer says it's not working at all, okay? While I'm up here, this is actually one where I just changed this AC right here. While I'm up here though, again, using my ears, my eyes, my senses, this AC is running. I just kind of did a walkthrough. And this compressor is short cycling and the condenser fan motor is not running. The condenser fan motor never comes on, and there we go. But the compressor is going on and off on overload, it sounds like. So they got multiple problems here. But let's start with the AC they called me about, which is AC2, this one right here. And we're gonna open up the electrical section. Now on these old Yorks, they're kind of a pain. Electrical section, this is actually bigger than normal, but it's this little cavity right inside there. So let's get it opened up. All right, we have a disconnect switch right there, and the disconnect switch has fuses in it. Now, we don't know if the fuses are bad, but if we start in here, the power from the disconnect switch comes and then goes into this first contactor. So if we simply just probe on this guy, and look at the meter, 209, we're gonna go line 2 to 3. Oops, not getting a good connection there. There we go. 209, and then line 1 to 3. This is a 3-phase system. 209. So we have 3-phase power coming into the contactor, meaning that the fuses are good in the disconnect switch. But what is causing this guy not to work? Now we do have a transformer right here, and it does have leads on it, so we can easily test the transformer right on the top to see if we have 24 volts going out. So let's see what happens with that. Put this guy right here where we can see it, and let's go to the transformer if I can get in here. There's one, and there's one. Okay, so transformer has, if I can get that to focus, 26 volts coming out of the transformer. So now it's in the hands of the thermostat and the compressor lockout board. So let's go up here to, I'm looking at the thermostat, I think it's X. This thing doesn't have a common, and R. No, it's not that. Where is it? What is this guy? I can't remember. Let me look at this real quick. I just wasn't on it right. So X and R have 24 volts, X being our common. So now if we go from R to Y1, we have no call for Y1, and Y1 and Y2 are jumped out, which is not ideal, but it does happen. So we have no call for Y1. Why is that? What is going on? The thermostat should be calm. Okay, they're on an EMS system, so I gotta call energy management. For now, I jumped it out, Y1 to R. And here's what we got. We got a condenser fan motor that's stalling. It didn't start very well. And then we have this condenser fan motor that wasn't running at all, and it was just making that noise, and the contactor just shut off. So I think we got 2 condenser fan motor problems here, and the amount of heat being rejected out of that's pretty intense. So let's shut it off and let's turn it on again. Let's give it a second for the fan motors to stop. These are really old motors here. Like, it's just slowly starting, like it has a cap going bad, and then that one won't start at all. So we need to investigate those guys. So let's shut it down, and let's investigate these guys, check the capacitors, and see what's going on here, why these are being a problem. This motor over here, I'm not seeing any major problems, but it spins, it's got a lot of rust on it, so something's going on there. But this one right here, looking at it, does anybody see what's wrong with it? Notice how you can see that right there, that much play. Look at the shaft. Yeah, that's not normal. So this guy's dead. This guy's got completely destroyed itself on the inside. This one though, I don't know if there's a problem or not. We need to see what it is. It might just be a bad cat. All right, one of them is at 10 microfarads. That's this one, and that's what it's supposed to be. So this cap is testing good. Let's test the other one. I don't know which one's for which at the moment. Okay, I disconnected one of the caps because I want to see which one's which. So, okay, see how this one has a real slow start? Okay. So what that tells me is that this cap is for the motor that we know is bad, that has bad bearings, because This one was still hooked up for the common and it was running. So we need to open this up and see what the cap is testing at for this guy right here, because that's the one that's doing a slow start. So the cap for the motor that's starting slow is actually testing bad, 0.27 microfarads. So yeah, wait, I scratched it. No, it's like still testing bad. I like moved it around. Looks like it might be testing at 5, but still not what it's supposed to be. So let's go grab a 10 microfarad cap, see if we can get the one motor going, and then we'll definitely have to replace the other one. All right, what I did temporarily was disconnected the compressor that has a definitely bad condenser fan motor. That is this contactor right here. I disconnected it, okay? For now, it's just pushed out of the way. It's 24 volts right there. This one pulled in. Contactor actually doesn't look bad for as old as it is. I put a new capacitor on that motor, and we are running at 2.55 amps. It starts up right away. And if I remember right, it should be running 3.2, so I think we're probably okay. I gotta peek my head around, but it looks like this was just a bad capacitor. Yeah, it's a standard 1/2 horsepower motor. It's just a bad capacitor on that one. So I changed the cap, that one's up and running. It's rejecting heat, cooling down the space. This one, we need a new motor for. This one is shut down and not running at the moment. I'm trying to cool down the dining room. And then I'm gonna jump over to this unit and see if it's a capacitor problem or a condenser fan motor problem on this one, because it's short cycling and I'm not liking that. So, and the compressor's going off on overload. So let me get in here and check this cap. This is a giant mess. The motor looks like junk, but it spins nice and free. But this capacitor, I don't know why it's in here. It's ugly. I just pulled the wires off of it. The cap's testing good. So I'm gonna disconnect this right here and test power at this and see what's going on, why the condenser fan motor wasn't, I don't know. I don't know if it has voltage or what. What a mess. I hate these older units. All right, let's see what this does. See if it turns back on. The thermostat's gonna give it a delay now. Okay, so that one's running. This one has 208 volts and it's not running. Condenser fan motor, but the compressor's running. Suction's cold and discharge is hot. So pretty good odds it's just a bad fan motor for this one. So we're gonna figure out which contactor's which. We're gonna disconnect the one for the compressor that needs a fan motor, and I'll get this unit going too. That way we have 2 units running while I go get 2 fan motors. And I think I disconnected the right one. Those contactors look like junk too. These ones actually look worse than the other ones. But let's have a look here. How bad are they? I mean, they're not that bad. They look like crap. They're dirty though. We'll make a decision about that. All right, so now it's back on. So it should just be this one turning on. Yep. Okay, I'm gonna disconnect this really quick, get the cover on, and let it run. All right, the supply house only had one of the 2 motors that I need. So the customer wasn't complaining about this unit. Another supply house has them, but I'm not gonna be able to get the motor before we go into overtime. So I'm gonna go ahead and I'm gonna leave this one alone. This is the unit that they didn't call me about, but they gave me approval to fix. This is the unit they called me about. We're gonna go ahead and change this bad condenser fan motor right here and hopefully get this one up and running. Now this one right here, I like using OEM motors, but on something this old, the OEM motor is gonna be ridiculously expensive. Aftermarket's good as long as you install it properly. I don't like the idea of wires coming out the top. We'll put those down inside. We'll do our best, but this really is polishing a turd. So we're gonna make this aftermarket one work. Now this is a really old motor. So what I did, the shaft is pretty beat up, but we should be able to get this off. I went ahead and put some penetrating oil on here. We're just gonna let it sit, and I'm gonna get some sandpaper, and we're gonna sand this up nice and clean. And then we should be able to twist this off the shaft, hopefully. Don't have a tripod, so I couldn't film this, but all that I did was clean up the shaft. I ended up cutting the shaft. I was about to use my puller because I was gonna have to cut it anyways. But what I actually did was held the blade, and because the shaft had play, I used it as a slide hammer. So I let the weight of the motor and just held the blade at a sturdy point right here where it wasn't gonna bend anything, and just shook it, and it slid right off after I had cut it and cleaned it up really good. It was just getting stuck on the little bumps from the set screws is all. So now we're gonna get the old motor off, get the new one in, and hopefully get this thing running. All right, the motor was a pain in the butt to get off. I had to pull the old one apart into pieces and pull the through bolts out. But regardless, this thing has weep holes, weep plugs right here, okay? There's one right here, or there should be one right here. I don't know where it is. There should be two on the top. There's one right there, and then there should be one right there. And then there's one here and one here. What you do is you pull the ones out on the side that's going to be facing down. Actually, no wonder that one's missing because I have it in my hand. Duh. So we're going to leave the top ones in because the shaft is going to be down. So we don't want the top to fill up with water, but if there was condensation in there, you want to pull these out so that way it drains out but doesn't fill from the top. Understand? So those are just weep plugs. It's a weep hole in case condensation builds up. Gravity will pull the water down, but you don't want it filling from the top, so leave the top ones in. And if they're not in the top and they're in the bottom, flip them around. All right, we're gonna get this guy mounted. Shaft spins nice and good, and get this thing put back in. All right, this guy's installed. I know it looks funky, but I use zip ties to keep the wires from rubbing out because you don't have the spot for the conduit. I don't even think you can get that stuff anymore. They used to have like a little piece of conduit that would run there, or a little channel or something. But zip ties work as long as they, you can see we've done it on this one before too. So looks like maybe we need to replace some of those zip ties because they don't last forever. But regardless, this guy's in. It's not hitting anything. It's not anywhere near. The pitch is decent, just barely going up into the cone. So we should be able to put this on and check rotation. Hope it's going in the right rotation, actually. That would be a nice thing. Yeah, it looks like it's gonna be, because looks like yellow to yellow, white to white on that one. So that's how I have it on this. All right, 1, 2, 3, please don't blow up. Okay, it's running. And let's make sure it's going in the right direction. And it's not. Good grief. So I do got to reverse the rotation. So, oh well, I'll flip it real quick. The reason why the old ones were sticking up was so it was convenient for someone to reverse the rotation. This is one of the reasons why I don't like aftermarket motors, but on the plus side, you know, for the most part, you can have one of these in your truck and it'll work for almost anything. But all I got to do is get to these two, which I had taped, just pull the tape off and flip any of the two wires. So orange is going to go to yellow now. Let's try this again. Good. Moving decent amount of air. Feels good to me. So we're gonna let it run for a bit, put the panel on. I'm gonna just make sure it's got somewhat of a TD, and we're gonna come back because we gotta change the fan motor on the other unit. We're not gonna waste too much more time because we're already into overtime. So for today, and all intents and purposes, we're just looking at the supply temp, 54 degrees. It's about 78 degrees in that dining room right now, I know, because it's nice and warm. Both compressors are running, both condenser fan motors are running. That's all they're getting for today. We'll big picture this tomorrow when we're not on overtime. I am back today, so now what I'm gonna do is I'm just gonna finish up on this AC, then we'll jump on the other one that needs a condenser fan motor over there. But first and foremost, we're gonna open up the blower section, make sure the belt's nice and tight, look at the shape of the evaporator, then we'll probe up on it with all of our pressure probes and make sure the unit's doing everything it can. This is an old unit, so I'm not expecting it to be, you know, the most efficient thing in the world, so we'll see. All right, the belt is not bad. Nice and snug. There's a spare in here for emergencies. And then the evaporator drain pan's clear. Doesn't look like any issues with that. Okay, well, it's time to turn this guy on. We'll have to jump it out because the EMS system's not going to call for cooling right now. It's kind of cool outside. So we'll jump it out and see how the unit's doing overall. All right, I've got my pressure probes, my temperature clamps, all on the suction, liquid, and discharge lines. You can see the discharge down there, same on both sides. This is my first stage, this is my second stage. So put the panel up and then start the unit up. All right, because it's on an EMS system, I had to jump out the indoor fan too. And I really don't care for when the wires are stripped like this, but whatever. It's kind of junk. All right, so let's go to second stage. Our temp split's a little bit low, but it's still kind of stabilizing out, so let's give it a little more time. But other than that, I mean, we are not looking bad. This is a 7.5 ton unit. Let's give it some time, but superheat's coming down. We'll give it some more time to stabilize out. I mean, that does seem like a high superheat, but super inefficient unit, no insulation on the suction line. Like, it's all affected by everything. So let's see. So that's circuit 2. Subcooling's a hair on the high side, but we're not getting a true liquid pressure, and it's a fixed orifice metering device. So there's gonna be a pretty significant pressure drop across the condenser typically from liquid to discharge, at least I have seen. Let's go to circuit 1. This thing certainly could use some love. Subcooling's a lot lower. Superheat's still a little bit on the high side. Saturation temperatures, I mean, you know, this is not gonna be perfect. This unit is beat down, like beat down. I really wish that subcooling was lower. I almost wonder if we have a restricted metering device or possibly a restricted dryer, I don't know. Let's look at our TD. TD's getting a little bit better as time's going on. All right, I'm gonna let this run for a few more minutes, but this customer is gonna need to consider replacement of this unit because it's not really worth a whole lot. Like, look at this condenser. This thing's trashed. I mean, you touch it and it bends. The fins are just done. They really need to consider replacing this thing. These are the last 2 of the ancient units. Everything else has been changed out for the most part. There's a York Predator over there. So, all right, well, let's let it run a little bit longer and I'm gonna jump onto the other unit. All right, it's getting better, but there's not a whole lot we can do. The temp split's going up. We're almost at 17, which is what we're actually calling for with the temperatures and the humidity and everything inside the building. So we're almost there on that. Airflow is relatively okay, but here's my logic here. Subcooling's high. 31 degrees, I mean, typically you'll see 15 to 20 on a system that you're on the discharge line. 31 degrees is high to me. Superheat is high. The superheat may indicate that we're low on charge because this is a fixed orifice metering device, but we're stacking liquid in that condenser. Or the other thing we could be doing is maybe we're not rejecting the heat enough because this condenser might have been released from the fins. So it may not be absorbing heat. This whole unit is just trash. So, I mean, what we could do if we wanted to know 100%, we could recover the charge from both circuits, weigh it back in, and see where that gets us. But this unit, I think, is working as best as it can. It's not gonna get much better than this. First stage looks a lot better. That I'd be happy seeing. The subcooling's still on the high side. I'm sorry, the superheat's still on the high side, but I mean, this thing is doing everything it can for a ancient piece of junk. You know, you can only do so much with this. There's not much more we can do. So that's it on this one. This one is working as best as possible. They really should consider replacing this unit. There's quite a bit of room here, so it would be possible, but that's a decision for them to make. I got it up and running, changing the condenser fan motor, putting a capacitor on it, and that's pretty much all we can do right now. The belt's tight, so like I said, we're gonna jump on the other unit now. This CTXL Vito bag is still one of my favorite bags just because you can put so much in it. Condenser fan motor, bandsaw, sawzall, grinder, drills, everything, pullers, all fits in there. You can pick it up from TruTechTools.com. Use my offer code BIGPICTURE. You can get an 8% discount on most of the items, and then I get a small commission. So again, that's TruTechTools.com. All right, I don't like the hub on this side. I like it the other way. That way you can remove it easily, but we'll see what we can do. I don't know if I can get in there and cut that without damaging the blade. May or may not be able to, we'll have to see. I was able to get in there with the Sawzall with the torch blade on there, and it cut it off. So those are the screws to take the hub off, right? It's a universal hub. The problem is that you have no good way to get an Allen wrench in here. Now you can use long shank Allens, but it's still not gonna go in straight because you're having to like go up and over the blade. Same thing on this side. It's really difficult, wherever the other one's at, over here, it's really difficult to get to. So that's why I prefer this hub being on the other side. We're gonna be able to salvage this blade, but I actually brought a new hub because I carry those in the van. So I got a new hub right here, universal hub. So we'll be able to just unscrew the hub and then reuse the blade is the plan. All right, the way that I have it on is the screws for the hub are gonna be on this side, okay? Now I realize the weight is pulling down on those screws, but they've got Loctite in them. I usually have good success with those, and it makes changing this easier in the future. Now I realize some people say that it's putting force on it and pulling the blade off and the blade's gonna go tumbling. I mean, just make sure you get everything nice and tight like it's supposed to be. And then if the customer's doing normal routine maintenance, you know, they potentially won't run into this problem because you should be able to catch, you know, a wobbly condenser fan motor or something like that. But, you know, you can only do so much when you're dealing with ancient relics like this unit. So I got the blade in. Oh man, I didn't realize that blade has a big ol' plump in it. That's not good. I wonder if this thing vibrates. Look at that. That's not good. We might have to get a new blade. Dang it. I just seen that right now. That looks like it was hitting something at one point, like a lot. Okay, well, what I'm doing right now is toning out the wires to make sure that I have the right wires, because I'm hooking it back up to put the capacitor over in the electrical section. So I've got the wire grounded out on the other end, right? And then we're just toning them out to make sure we have the right ones using the tone feature on the meter. If I did everything right, nothing should blow up. Okay, so far. Let's push this contactor in, see what happens. That wasn't a blow up. That's the condenser fan motor. Let's make sure it's running in the right direction. It's not vibrating, so whatever that little wobble in the blade is, it's not messing things up. Let's make sure it's actually going in the right direction. I think it is. That was just this panel falling off. No, how is it going in the wrong direction? I switched it around. Oh, the blades must be different on the other one. I flipped it to the same way that the blades were on the other one. So it is going in the wrong direction. It must have had a different direction blade. That's what you get for assuming, right? But no, everything's good on that, so we're gonna flip it back around the rotation. All right, this AC seems to be doing really good. There's a weird, sounds like maybe a bearing going bad in the indoor blower motor. I can hear it from here, but look at our operations. Sat temps, 36 degrees saturation temp. It's an R22 circuit. Superheat, you know, right on the line. Subcooling where I'd like to see it. Second stage is pretty much looking the same. I mean, that's looking pretty darn good. Let's go over to temp split. It's funny, it's doing about the same temp split as the other unit. It's probably like a probe placement thing, and airflow seems to be on point. So this unit is kind of on its last leg too, but it's running. We got a fan motor in it. Both compressors are running. Belts are tight. Contactors all need to be replaced. Coils are trashed on both of them. Disconnects are crap. When you slam them on and off, they don't, you know, they don't actuate right. But it's running. It's polishing a turd. This is the best we can get on this unit. Customer will be happy to have something going into our first little heat wave of the season. We're in this weird, it's currently April 12th, and we're in this weird thing where it's gonna be 93 degrees today, but then tomorrow it's gonna be in the 60s for the next 3 days. But then next week it's supposed to be upper 80s, low 90s. Like, this is our transition into, you know, spring, summer kind of ish. And then we'll be into the 110, 112 degree, 120 out in the desert. It'll be nice and warm, but that's all we can do on this, all right? We're got them up and running. We're gonna give them recommendations on replacing both of these units. That would be a very smart decision on their part, but it's their money, so we'll just see what they wanna do, but that's it on this one. We're gonna give the customer the keys and tell them to keep an eye on it.
When you have equipment this old, there's only so much you can do. And at what point do you stop fixing things, right? So it all depends on the customer and what the customer wants, and it depends on your relationship and your management and how they want you to proceed. In this situation, I know this customer, and I know they don't want to spend a ton of money fixing stuff, right? They only, you know, they have a limited budget, so they only want to get it going, especially on something this old. Because if I was to tear into these units, right, at a minimum, in a perfect world, we need new condensers, which isn't happening on something this old. Okay, you're just not going to get them. But if we put a new condenser on here, new dryers, maybe even pull the metering device because it's a piston, make sure it's clean, new refrigerant on the first unit, all new contactors, both condenser fan motors in a perfect world, right? That one that was acting really funky would probably be a pretty good unit. It would probably work again. Very inefficient, right? Probably 8 SEER or something like that. Very inefficient, but it would work, okay? Now the other unit, you know, all new contactors, new indoor blower motor, possibly new blower bearings for the blower assembly, these units aren't really worth that much. And that's the customer's opinion too. But at the same time, they don't know if they can get corporate to approve replacement of new units because they already put 2 brand new units on the roof earlier this year, or, end of last year, early this year. So it's just not in the budget right now. At least that's what they want. So, not every one of my customers lets me go hog wild just fixing everything. I think I give that that idea to people that like I could just do anything I want. And that's not necessarily the case. With different customers, they want to do different stuff, right? And every customer is different. So as a business, I have to approach each job differently, knowing the customers and communicating with them and asking them what they want. So in this situation, they only wanted to get the units back up and running as best as possible without changing a bunch of unnecessary parts. Well, what they deem unnecessary. I mean, at a minimum, I would have loved to have changed the contactors, but you would have had to change all 3 contactors on both units because they were just completely trashed. But I mean, I've seen worse, And that's the kind of stuff that I bring to the customer's attention. But at the same time, I don't want to overload them, But it's like, hey, we got to do the condenser fan motors. And we really should put contactors in there because those will probably save the life of the compressor because those contactors eventually will become so pitted that it'll start to single phase the compressor and then they might lose a compressor. I don't know, but the customer didn't want to do that at this time. They only wanted to do condenser fan motors and capacitor. And that's okay. I'm okay with that, as long as I have documented and informed the customer on both of the invoices. We had 2 separate invoices on both of them. I wrote, both of these units need to be replaced sooner than later. They are both inefficient, and I don't want them to go down in the middle of the summer. And I've given them my recommendations. And if they choose not to have me replace them, then when it breaks down again, and I told the customer too on site, I said, look, I can't promise you you're not going to have another problem in another month because these units are just trashed. It's time to replace them. On paper, if we did the math, we put so much money into these units. Every York package unit on this roof, all the old ones, we replaced the heat exchangers in them probably about 6 years ago, and that was a debacle finding all the parts for the heat exchangers in these things. Like we've been telling them to replace these units forever, but it is what it is. It's okay. I'm not the kind of contractor that's going to go in and say, no, I refuse to fix these. You have to replace them because they'll find another contractor to fix them. Right. So I give them a recommendation and then I say, I suggest you repair them or replace them. But if you don't want to, here's what I can do to repair them for now. Understanding that you're going to continue to have problems, and, they make their decisions. So that's the way that I choose to do things and the way that I choose to interact with my customers. And it's okay if you do it differently. It's just in my market, in my area, this is what I have to do. So another thing to understand is that first unit that I started working on, pressures were really weird. I mean, nothing makes sense about high superheat, high subcooling, normal refrigerant pressures, high and low side, well, somewhat normal, right? That doesn't add up because normally if you have, low superheat, you're going to have, the pressures aren't really reacting with the way that they should be. So there could be some inefficiency in the compressor. Like I said, though, there's no insulation on the suction line. Like there's so many different variables that come into play here when these units get this old. I think that the condenser has, I don't know if it's called delaminated or separated to where when they construct these condensers, it's a tube and fin condenser. So it's a copper tube with aluminum fins that are expanded and they slide on the copper tube and they grab it and they help with the heat transfer, right? They help to grab the heat. Well, those copper fins, I don't think that they're making good surface connection with the copper lines anymore. So I think that's affecting things too. But when you start going down that logic, well, if the condenser is damaged, well, then how come the head pressure is not extremely high? There's so many different weird things going on in here. So in order to really diagnose this and dig into that AC even more, at a minimum, like I kind of mentioned in the video, recover the charge, put new virgin R22 in those units. They're a fixed orifice. I personally don't have very good luck using alternative refrigerants with fixed orifice devices, especially since these are mineral oil and they're old compressors. Now, if I was going to use an alternative refrigerant, at a minimum, we would need polyester oil in that compressor. I don't care what refrigerant manufacturer says that there's work with mineral oil. My personal experience is none of them work good with mineral oil on fixed orifice metering devices on something this old. You know, that's just my personal opinion, right? So, you know, we could start with that. We could new refrigerant, change the dryers, check the pistons, make sure that they're clear. You know, we could do that, pull a good vacuum on the system and then see where that gets us. But that's a lot of money. Each one of those compressors probably holds, what, 7 or 8 pounds of R22? I mean, that's a lot of money for that customer, you know, to spend. You know, and if it gets to that point, if in the summertime it really doesn't keep up and they still don't want to change the unit, well, then I'll recommend that. This is where we can go. But I'm always going to fall back on, you really need to change this unit. You really need to change this unit. It's lived its life. It's done. And then if they say, no, it's not in the budget, well, then I'll give them a quote to, you know, change the refrigerant, put new dryers in it, clean the piston, you know, and try to straighten out the condenser as best as possible, give it a good cleaning. I mean, you know, there's only so much, right? So I try my best. I'm not an expert. Please don't think that I'm an expert. I'm just a guy that's, you know, stumbling through this, trying my best, using dumb logic all the time. That's what I always do, is just kind of, okay, well, if this is happening, you know, just kind of think your way through it. And that's who I am, right? So I really appreciate you making it to the end of the video. Thank you so very much. If you haven't already, please consider subscribing to my channel. If you want to support the channel, there's a couple different ways, but the easiest way to support this channel is literally just watch the videos from beginning to end. That really is the easiest way, right? You can also support it via TrueTech Tools. I mentioned in the video that Veto bag that I use, and I really like it. You can get that from TrueTechTools.com. And if you like it, you like their pricing, you can use my offer code BIGPICTURE, one word. You'll get an 8% discount on majority of the items on their website, and then I get a small commission, and that's a great way to support the channel. You can support the channel via PayPal, Patreon, YouTube channel memberships. There's links in the show notes. Those are just monthly commitments that you make. You can also support the channel by going to my website, hvacrvideos.com, and purchasing merch. We have hats, beanies, sweatshirts are still on clearance or discount at $25, which is basically less than my cost. And in the United States for the zip-up hoodies, that includes shipping too. So pretty good deal. Yeah, beanies, stickers, all that good stuff on the website. So again, thank you so very much. I really do appreciate you, and we will catch you on the next one.